Last night, most of you here should have heard a concert. It occurred as part of a series of concerts we have sponsored now in several cities, as well as in other countries around the world, in which very fine artists have been demonstrating the power of performing classical music at the God-given pitch of C equals 256 cycles per second, a principle rediscovered in our time by Milan LaRouche, which has been effecting a musical revolution. What I am about to do, with your help, is to tell you what you heard last night. To refresh your memory, I have asked John, well, Monica's not here right now, but John's going to, you're going to help him, Margaret? Okay, fantastic. I've asked John and Margaret to present the opening of the fourth song in the Brahms Shuna Magalona cycle. And if you don't have the words with you, that's good, because this time I'd like you to give all your attention to the musical line. Thank you. Since the Council of Florence, this quotation will become important later in our discussion. Since the Council of Florence, great classical music has been a secret weapon for our political faction, namely those who identify man as made in the living image of God. What is it about classical music composition that increases the self-conscious creative abilities of men and women, and thereby strengthens their capacity to defeat the forces of tyranny and slavery? It is impossible to answer that question without becoming more familiar with the material from which musical thought is constructed. That is why Mr. LaRouche has asked us today to conduct a demonstration in which you will participate, in which we will aim to make you more familiar with what is called the well-tempered system and the material from which musical thought is constructed. Musical ideas are not constructed from notes. Musical thought begins with musical intervals. There is a mistaken perception in our culture that these intervals are just distances or interactions between the notes. They are not. The intervals are a primary form of existence, what we should name a form of oneness, from which we can generate a many. The primacy of the intervals will become clearer as we move from looking at intervals to reviewing pairs of musical intervals. These pairs of intervals may involve 4 or even only 3 notes. It is these pairs of intervals which generate the first level of hypothesis in musical thought, namely the alternative choices of interval which can be generated between the intervals. On the screen, you now see a list of the musical intervals. octave, fifth, fourth, major and minor third, major and minor sixth, the half and whole step, and then the augmented and diminished intervals. One of the intervals we will be working with today in particular is the fourth. So that you can begin to become familiar with this fellow, the fourth, I would like to ask Margaret to play two ascending fourths, C to F, then G to C. And I would like everyone here to please sing them. Margaret, please play Do, Fa, Sol, Do. Okay, I'd like all the ladies first to sing Do, Fa, Sol, Do. And now, would the men please sing the same thing? Thank you very much. Let us further orient ourselves by locating what we just did within the musical domain, which is the audible portion of the electromagnetic spectrum. The chart above provides an overview of the musical domain. It begins at C equals 64 cycles per second and continues through to the F in the octave of C equals 1024 cycles per second. We have here a bassoonist and a violinist. They will, in succession, play the sequence of octave Cs. Mindy will play from the bottom of the bassoon C64, 128, and 256. Nancy will pick up at C256 and play that through to the 512, 1024, and then C, D, E, F. Mindy? Just play C. Thank you. That is basically the range of the musical domain. The fourths you in the audience sang were for the women in the octave of C equals 256, and for the men it was located in the octave C equals 128. Embedded in each octave, there are 12 intervals. In this way, the musical domain conforms to visual space. The duodecahedron, which we now show you a picture of, which Nora showed you a picture of earlier, with 12 pentagonal faces, is the maximum polygon which can bound physical space when all the faces are the same. Now, I want to pose the following problem to you. Do you believe that there are any notes lying between the 12 tones of the well-tempered system? Do you believe that there can be more than 12 tones in the well-tempered system? This question was first rigorously posed in ancient Greece by the Pythagorean school of geometry, and since that time there have been efforts in Greece, more extensively in India, and also in jazz today, to build music out of smaller intervals, such as the quarter tone, or what today is called blue notes. Despite such efforts to build music out of smaller units, there exist no notes between the tones of the well-tempered scale, the values of which are God-given, and existed even before they were discovered by humankind. We shall now examine this principle of the well-tempered system in two ways, which will prove that the 12 tones, which form 24 major and minor keys, or modes, are the only possible values for musical tones if we desire to have intelligible concepts in musical form. We will show this first musically, then second physically. First, we will show that it is the absolute value of the well-tempered domain which allowed us to generate hypotheses. In music, hypotheses arise from pairs of intervals which generate a lawful range of choices of intervals lying between or potentially generated from the pairs. That is the first level of hypothesis in musical form. To musically demonstrate this, we must now incorporate a fundamental aspect of the well-tempered system. On the screen, you can now see the next graphic, which is our now famous chart of the 6 species of human voices, which is the hallmark of the Schiller Institute's music manual. Throughout the human population, there are 6 species of singing voice: soprano, mezzo-soprano, the rarer contralto, tenor, baritone, and bass. These voices punctuate the musical domain in a precise way. Each voice has 3 or 4 registers. The registers are like intervals. They are spans in which all the tones have the same timbre or color. Singers use terms such as chest voice, central voice, and head voice to distinguish these registers. The registers change at precise pitches. For example, for the soprano, the tone on which the register changes is F sharp, which is smack in the center of the octave C to C. Thus, earlier, for example, when the women in the audience sang do, fa, the interval of a fourth, those women who are sopranos sang do, fa in their chest register, and do, fa, and sol, do in their central register. The shift from register 1 to 2 occurred in a discontinuous area, sometimes referred to as a wolf tone between fa and fa sharp. These registers give a very differentiated and distinct character to the musical spectrum, allowing us to generate a lively, multi-voice dialogue of musical ideas. What we will demonstrate in respect to the intervals is that they can be placed anywhere in this musical spectrum. Because the great composers worked from richly experienced concepts of the intervals as the primary form of existence, they were able to use them as a form of the one from which to generate a many. The natural differentiations colored in by the registers, as we will see, enrich the potential power of the intervals. Let us illustrate this. We are concerned today with the interval of the fourth, as we've been singing. Do, fa. Let's become more familiar with it. Would everyone here please sing with me, beginning on C256, the following, the notes for which are in the next graphic on the screen. Namely, do, re, mi, fa. Would everyone please sing that? Now, do, re, mi, fa. Thank you. We have progressed the distance of a fourth, but if I were to be honest with you, I would say it was not a very musical idea. The reason is that it is too much like a school book exercise. And instead of being conscious of the fourth, what I hear is the repeated whole step. Do, re, mi. That repeated whole step is boring and overshadows a clear concept of the fourth. Let's try a different approach. Instead of repeating the whole step, let us skip the middle interval and just sing do, re, mi, fa. Would everybody please sing that? Do, re, mi, fa. This gives us 2 pairs of intervals, do, re, then mi, fa. The first is a whole step. The second is the smallest musical interval, a half step. Interestingly, it is much easier to hear the fourth because of the difference, the change between the 2 intervals. As Plato would recognize, this change in species of interval facilitates our consciousness of the fourth. Let us go a step further. Let us intensify that change by not only altering the interval, but also by altering the direction. Namely, instead of singing do, re, mi, fa, in which both intervals move in the upward direction, let's sing do, re, and then reverse direction to fa, mi. Let's sing that. Do, re, fa, mi. We'll have to do that again because people got caught on. Let me sing it once with the piano, and then we'll do it all together. Do, re, fa, mi. Sorry, I've gone sharp. Do. Okay, let's do it again. Do, re, fa, mi. Let's all do it together. A little bit, let's do it a little bit slow, just a tad slower, Margaret, okay? Do, re, fa, mi. Oh, that was much, much better. Now, some of my associates here have undoubtedly grasped what has occurred. For those who may not know, that is the theme of the final movement of Wolfgang Amadeus Mozart's Last Symphony, number 41, also known as the Jupiter Symphony. Do, re, fa, mi. Let's hear the symphony so we can appreciate how Mozart set the problem up. Would John Cavici please put on the tape? Follow what Mozart does with that pair of intervals, ascending whole step going to descending half step. Do, re, fa, mi. We will advance in our knowledge of what is meant by the interval between the intervals. Mozart has generated or created the interval of the fourth through the principle of change, which is fundamental to how intervals work. How do I know that Mozart wants to accomplish exactly that? To generate the interval of the fourth. Because after he writes do, re, fa, mi, he leaps to la, 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 la. Well, what interval is that? Namely, mi to la. It is again the fourth. I'll present this another way. This theme that Mozart has developed traces back to material that many people in this room studied 1 year ago. At that time, we sang Mozart's Great Mass. And the fugue was derived from a fragment directly related to this. It was the Cum Sancto Spiritu. And all the people in the chorus know it. Do, fa, mi, la. Namely, the same two ascending fourths. The Jupiter Symphony, written just 10 years later, is based on related material. There is an added dimension to this. The second fourth, the leap from mi to la, occurs across a shift of register. In a recent communication, Milan made the following comment in addressing what is created between two species of interval. He stated, quote, "The change from one registration to another is a very special kind of interval, analogous to, but different from, the otherwise defined interval. If you combine it with an interval, combine its quality as a simple interval with the scale, with an interval of registration, we really begin to have something in the manner of an exotic Lollapalooza, which we can really do some work with." I would like to introduce you to what Lyndon LaRouche has called an exotic Lollapalooza. I would like to ask Nancy Shaven to play on her violin the opening 18 measures of the violin line of the Jupiter Symphony, the notes of which are now also up on the screen so that you can concentrate on that leap from mi to la across the registers. If there's any problem here, she'll move to the microphone, but I think you'll hear her fine. Notice how Mozart presents the poetic statement 2 times and then appends a postscript so that we have that fourth, that leap from mi to la, yet a 3rd time. On the violin, by the way, the change of register from mi to la is performed as a change of string. The first 4 tones, all of which lie in the soprano 2nd register, are played on 1 string. The la, 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 which lies in the higher 3rd register, is played on the next higher string. Nancy will demonstrate one one iteration of that in slow motion so that you can actually see her pick up her bow from one string and push it over to and put it over to the next one. Yeah, just, yeah. You see, she had to pick her bow up to go to the next higher string. So, what can we do with this Lollapalooza? It is the change of register which allows us to form a concept of a higher order than simple hypothesis. Let us discover how Mozart views the problem of the interval between the intervals. Mozart will now take this composition through a process of development. What do we mean by development in music? LaRouche has stressed that what we call development in music is a process of exhausting possibilities, the aim of which is to achieve the same paradoxical result which Nicholas of Cusa was addressing in the problem of the quadrature of the circle. There is nothing mystical about musical development. It is a process of linear exhaustion, of creating internal and external polygons to evoke the necessity of a higher species. The concept of the piece is not the development, but is the bounding higher order of existence which the development provokes us to conceive. Mozart will exhaust the possibilities of elaborating the fourth. This will allow him to potentially generate a new lawful choice of intervals, leading, in the case of this composition, to a very exciting scientific discovery. This process of exhaustion and discovery will then be summarized or brought to a point of completeness intended to summarize the entire composition, including earlier movements which we will not look at today. The result will be a presentation of harmonic unity, paralleling such harmonically unified forms as the Acropolis built in ancient Greece, where a single concept of harmonic relations unifies the entire composition. How does Mozart do this? Soon after the presentation of the opening idea, he contracts the opening statement from 4 notes to 3. This contraction from 4 notes to 3 focuses our attention on the fourth and excises out the half step, which will come back later. Let us first hear this on the tape recording. John Cavici. Nancy will now help us review the 3-note versions of this as it appears in the second and first violin parts. First, measures 36 through 43, where she will play first the second violin voice, then the first violin voice, although in the actual piece, as you heard and see, they are in a canon and overlap. Thank you. Remember the interval mi, la? That leap of register in the opening phrase is now being developed. A few things are going on at the same time. The leap, mi, la, is now represented by moving the entire 3-note phrase into the 3rd register. Whereas in the opening, the 2 registers were in a single voice line. Do, re, fa, mi, la, 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 presented by the first violin alone. Now the 2 registers have become 2 voice parts, a duet between first and second violin. Now Nancy will play the second 3-note version, which was at the tail end of that tape that we heard before. This is the violin 1 part. Thank you. Here, Mozart emphasizes the change of register in a different way. Notice how Mozart is working with the critical singularity of F sharp, the value at which the soprano voice moves from register 1 to 2. Although some of the audience may be unfamiliar with the term I am about to use, I will mention that by introducing the F sharp, Mozart has created a new mode, linking the scale of C major with that of G. In other words, the developmental potential of Mi-La, the Lollapalooza, has been shown by becoming two voices, namely polyphonic, and also now by unifying two keys into a new mode. Being a good geometer, Mozart will also turn the three notes upside down. In measure 74, violin 1 plays the following. Just play the first three notes just again. That second interval is an ascending fourth, of course. Now you can hear it as it is in the symphony. John Cavici. He has so much material now that for the next 80 measures or so, he will exhaustively iterate the unity of this material. This will be done by presenting it as a unified idea in the mode of C to G major minor. I am now going to skip ahead to the section which I referenced as a scientific breakthrough. I am leaving out an interim step, but I think you have a basis for getting a first appreciation of the breakthrough. It occurs beginning measure 233. I am going to play a recording beginning a few measures before on measure 219. You will hear four notes in the bass played by the cellos and string basses. If Mindy's bassoon is still out, I'm sure it's also in the bassoon line, and Mindy should play it because it'll be very, very clear on the bassoon. One more time, just play one more time. The intervals are four descending half steps. That is the same distance and downward direction as fa mi. After the exhaustive process of development, you hear this four-note bass line as an outgrowth of the original theme. There will then be a very short interlude, a repeat of the opening idea, and then the breakthrough. My tape of this is not so great, so this actually got messed up a little bit, but I promise you when you go home and you listen to the symphony again, you can't miss these four notes. But however, John Cavici should turn on the tape at this point. John can put up what we just heard, the score, the string voices of what we just heard, or three of the string voices. What is happening here is that he is taking the opening phrase and simply moving it up and down on the musical spectrum. The high point, lawfully, is La. But the breakthrough is not that he's able to do that. The discovery is in the relationship between that action and the entirely new laws of counterpoint he generates between the soprano and bass voices. Margaret will now play the top voice, the first, against the bass voice from those measures. And please listen carefully. Do you have a Xerox of it? If you want to leave out the fast notes, Margaret, that's fine. The soprano against the bass. You can leave out the middle voice too. It's just octaves, but you can leave it out. Do that one more time and then play that final B flat. You can leave out all the fast notes. That was very good. Just do it all the way through and play through to the B flat so people can hear that, because that's very pertinent. The whole thing? Yeah, the whole thing. Thank you. What is happening here is that he is taking this opening phrase and moving it along the musical spectrum. The counterpoint is entirely new. It is in the form of a discovery. In this passage, the entire well-tempered domain is unified into a single mode. No notes are outside the system. And the fourth we created at the opening is now lawfully generating sixths, across voices, sevenths, half steps, augmented fourths, and every other conceivable interval across the spectrum. All relations in the well-tempered system are harmonically ordered. I will only reference as a matter for follow-up that people should think about the impact of a passage like this, of this kind of discovery, upon Beethoven. As Beethoven would later do, Mozart summarizes the entire composition in a concluding fugue of a type that he himself invented, in which all previous material, including from earlier movements, is presented polyphonically. I want to highlight one point about that fugue which establishes the completeness of the composition. On the screen, we show the score of the string section of the orchestra playing that fugue. It is very significant that Mozart increases the voices of the string section of the orchestra from 4, namely violin 1, violin 2, viola, then basses, that he expands the number of string voices from 4 to 5. He does this by having the string basses break away from the cellos. It occurs earlier than, it's a longer passage where this goes on than just these 4 notes. These are exemplary. He has the basses break away from the cellos and play their own independent line in the fugue. This independence of the string basses will later be very important for Beethoven. This is very important in measure 328, where the string basses, the deepest instruments in the orchestra, play the opening theme, do, re, fa, mi, as an independent bass line in the lowest audible register, C equals 64. Guess what? That theme we've been discussing all this time, it's not a melody. It is what the composers call a pedal point. And as Brahms emphasized to his students, and we report extensively in the music manual, the entire art of musical composition rests upon recognizing the guiding role of the pedal point in composition. Now I will play a recording of this final fugue. John Cavici, is it on? Sorry. Unfortunately, this is a somewhat long space, so you might have to just fast forward a little bit. The intelligibility of musical ideas is embedded in precise musical values. We could not have followed Mozart's development of a breakthrough if the tones were treated like sloppy cups of coffee in which more spills out on the floor than reaches the mouth. Let's look at this another way. As Mozart and all the great composers were aware, the precise values of the tones had been proven by the astronomer Johannes Kepler in the early 1600s. Kepler demonstrated that the principles underlying the well-tempered musical system were the ordering principle of the planetary solar system. This chart appears in our music manual. It is a map of the solar system divided in two pieces to make it easier to read. The upper part is the inner planets, including Earth, which are made of heavy elements. The lower circle are the outer planets, which are composed relatively more of lighter elements. The triangular bands sweep out a ratio between each planet's closest and furthest distance from the sun. Following the method of Kepler, the author of this chart put those ratios in a series, here linked by the spiral. The values of those ratios constitute the musical scale. Namely, Kepler applied music to astronomy, not the other way around. The question is, do any orbits or planets exist between the given orbits? The answer is no. There is one apparent exception. The largest band on the inner circle at top is the area of the asteroid belt. That is the region where the instability of the orbit was so great that the planet in that orbit, the apparent exception, exploded. Notice that the value of the ratio of distances for the asteroid belt is F to F sharp, exactly where the soprano voice goes through a discontinuity, namely the register shift. Now we show a chart which is a thermodynamic model of the voice. This is why the human physical apparatus can sing. The pitches are wells, just as the orbits of the planets are. This model gives you a clearer sense why there must be an absolute system of tuning. The way this is accessed, which is called the Florentine bel canto method of singing, is that you aim for a purity of tone. You focus the breath and the energy to put the maximum in the tone and the relative minimum in expulsion as air from the nose or mouth. If you try to sing pitches between the well-tempered pitches, either for effect or because the tuning you have adopted is not based on C equals 256, the purity and efficient bel canto production of the tone will break down as it slides around between the orbits. When you put all the species of singing voice together, you get a well-tempered system. What we are seeing here is that music represents a principle, which becomes a principle of understanding the human mind, which we find applies not only to the way in which the human voice is organized, but rather the planets and other things. Today, generally, the term which would be used among physicists for such a Keplerian view of the universe would be quantum field. It is the action of change from one orbit to another which is significant, which is what we hear. The change from one tone to another, namely the interval. To build something, we have to have at least two intervals, as Mozart did in the Jupiter Symphony. Great composers such as Mozart have a very rich concept of what these intervals can do. We need to study these intervals, work with them, have fun with them, study how they work across registers and between different voices and instruments. That is what makes classical music a tremendous amount of fun and very rewarding at the same time that it enables us to master principles of generation of hypothesis and higher hypothesis. Now that we all here are experts on the matter of fourths, or at least rising fourths, I want to introduce you to a close relative of the ascending fourth. Let's return to the song that John and Margaret excerpted at the beginning of this panel. That song, Liebe kam aus fernen Landen, is based on 3/4, traveling, however, in the opposite direction from the Jupiter Symphony. They are descending. John will now sing the opening two bars without accompaniment. I'm sure that what you're thinking is, that is quite different from the Jupiter Symphony. That is absolutely correct. Intervals are quite different in their ascending upward versus descending downward form. That is why the well-tempered system has such vast potential for artistic creativity. You have the absolute pitches, the registers, and the intervals in their ascending and descending forms. The possibilities are endless, and the great composers were those who knew these intervals as living concepts. Let us illustrate two aspects of this song, which is valuable because of the way Brahms views the interval between the fourths as a much greater interval. It opens with the 3 descending fourths. Since he has descended so much, he then ascends. Here is also where the words become truly captivating. Love came from a faraway land, and no creatures followed her. And the goddesses beckoned me and enthralled me in sweet ribbons. The descent, then ascent of the intervals wraps around like the ribbons. Brahms repeats the phrase. The second time, the fourth generates a leap across the tenor first to second register of an interval of a ninth, a wide interval. I think we're going to, rather than have him sing it because of time considerations, you'll just have to play it out, sing it for yourself at home. Like in the Jupiter Symphony, moreover, the so-called opening melody is actually revealed to be the pedal point, the underlying unifying concept of the bass line. Composers rework these intervals, always looking for a new implication of the interval between the intervals. That is why the best composers always copied each other's material and copied from themselves. For example, at the last conference, we showed how Brahms's Fourth Symphony comes from material in Beethoven's late Opus 106 piano sonata. But Brahms also took the same material, changed the direction of one interval, and formed the opening pair of the song O Tod, of the Four Serious Songs, or in English, O Death, a song of great importance which we intend to present at future conferences for getting to that higher bounding conception which the elaboration of the interval between the intervals is intended to create for us. Thank you very much.
We now have precisely 20 minutes for questions, discussion, as people begin to line up at the microphone, which is somewhere, or will be somewhere, shortly, right there. Will be there as soon as someone moves it there, please. Let me read a few announcements. Parents can leave their children at daycare until the break, which will be at 2 o'clock. However, please come promptly to get your children then. There is no staff from 2 to 3:30. If you don't pick them up at 2, and I've been asked to repeat the room numbers of the earlier announcements, which I will attempt to do. The Bergonzi videotape will be shown in Pavilion Room 21. Bergonzi tape in Room 21 during the lunch break, and again in the same room during the dinner break. There will be an advisory board discussion in Pavilion Room number 23, opposite the bookstore during the lunch hour. And at the dinner break, there will be a discussion of the OBE campaign and the Spanish campaign in Pavilion Room number 23. And then the Schiller Institute board meeting will be where? Room number 5. Downstairs, room number 5, downstairs. Okay, now if we could please have silence so that the discussion period can proceed as efficiently as possible. Yes, sir. And if someone could turn on the microphone also. Can I ask the people in the room to please be quiet so that those who are remaining to discuss can do so? Hold your discussions until you get outside the doors, please. Shh. Thank you.
Jonathan, I am Bill Stadician from Ridgefield Park, New Jersey. Regarding the roulettes, the hypocycloids, epicycloids, evolutes, involutes, spiral of Archimedes, you brought up the non-algebraic ineffectiveness of representation. Could you elaborate on mathematical representation of the roulettes and possibly polar coordinates?
Well, the sort of thing that we're put through in so-called mathematics education, which is very bad if it's done at all. First of all, they're getting rid of it, but it wasn't very good before that either. You have to go back and read the classics, go back and read Bernoulli. It's so beautiful and so simple. the way the original people that were doing the work actually presented what they were doing, which of course is embarrassing for a lot of people that want to make money writing textbooks. But I think that there's a whole thing about this idea of the mathematical representation in terms of a formula. I say this for people that may be engineers and are used to writing cosine and exponential log and all these things. Think about what you're doing. If we start with, this is all just a shorthand for geometry, or let's say for physics, for actual physical processes, or possible or proposed physical processes. So if we start with the Euclidean geometry, and I mentioned you can then do things like adding and multiplying and doing proportions, and now you translate that into a shorthand, then we write things like x plus y and x divided by y and so forth. So we have a kind of algebraic notation, but it's talking about these kinds of changes. All right, so now when we move to this circular action and we generate a cycloid, we realize we have something of a very different nature. For example, something very simple. If we take a circle, or we take two circles and we intersect them, they intersect in 2 points, generally speaking, either no points or 2 points, or maybe one if they're just touching. And that's the general thing that we find. If you take a cycloid and you make a circle through it, you find, especially if it's a cycloid that keeps going, that it intersects the circle in an infinite number of points. You have a whole different kinds of things going on. And you find that there's no way to write down an equation, x so-and-so, x squared plus y, and so on and so forth, equals 0, gives me the equation for a cycloid. There is no such. So now somebody comes along and says, well, if we write down cosine and so forth, then we can make an equation for it. Yes, okay. But where do we have the idea of the sine and cosine, the so-called trigonometric functions? Well, that was something that we pulled from outside algebra and made a name for it. You can't reduce the sine and cosine to ordinary algebra, but you can take circular rotation, think of that as defining a function, and now give it a name, sine and cosine, and now start to use that as a shorthand. So I think that's the relationship. In other words, if we take our algebra, which doesn't function for the cycloid, and now we introduce a species of circular functions called the sine and cosine, right? Which is something that's coming from outside the algebra that we started with, then we can write down a formula. So I don't know if I've answered your question. That's the nature of it. And what occurred then, people get a little bit distracted from the algebra and forget that it's the geometry that comes first, and then you have a shorthand which can be convenient. But it's no more than a shorthand.
Yeah, my question's for Renee, and I was wondering why some instruments play in a certain key while other instruments play in another key. For example, the trumpet being in B flat, trumpet and clarinets, whereas strings are in the key of C, and why they developed it that way.
Well, you've actually asked two different questions. I'm a string player, and I don't completely understand some of the key aspects in terms of trumpets and clarinets, in terms of I mean, it's partly a question of the physics, but some of the more modern wind instruments actually can play in all of the keys. They're just focused around one or another key, although that's not the most perfect system. I mean, the voice, the modern day keyboard, the strings are 24 key domain instruments. The woodwinds in the orchestra, with the obvious exception that you can have concerti, which highlight one of the solo wind instruments. The horn in F, the trumpet in D, are coloring the general shape of the registers of the orchestra. They're not the central instruments. They're coloring the string family is the core of the orchestra, and they're coloring what the string family is doing. So in that way, that limitation is not a problem, okay? But it is a limitation. which some of the wind designers have attempted to override by changing the design of the instruments, but that has not been entirely successful. I mean, there are limitations in the structure. That's why the strings, it's one of the reasons, not the only one, but that's the reason that the strings are the central core of the orchestra and not the winds.
Why is it that they don't just call the B flat a C when it is a C to the strings, as far as, a clarinet playing? Because it's the same tuning registration, isn't it?
Yeah, these are transposed instruments. There are different, you see, when those instruments, what's going to happen is, from the standpoint of the absolute pitch, the register shift is going to move. It's like an oboe, the oboe d'amore or oboe da caccia does not shift register on the same note as the oboe. The oboe shifts register on the C sharp. One of the others shifts register on the A. So the reason they do it that way is I think the reason they do it that way is so that a performer who's got to learn 3 kinds of oboes can learn 1 set of fingerings. He doesn't have to constantly transpose every time he picks up a piece of music, although really super expert people would not have a problem with that. But that's almost like asking people to be a little bit like computers. So rather than forcing people to learn that kind of skill, which would be very frantic, frankly, for a lot of people to learn, you learn 1 set of fingerings, you read your notes, but basically just the person who's written out the music copies it out in such a way that the register shift falls in the right place.
Okay, thank you.
Yes, next question.
Mark Walker, Virginia Beach, Renee. From what you began to say, you're saying that music doesn't simply sound nice, but it was used basically to paint a picture. You talked about Mozart deliberately doing things to paint a picture with certain consequences. I would think of the Nazis that used music to paint a very nasty picture with difficult consequences. Going back on the first thing you said, are you actually saying that this is a real musical war with real physical consequences?
Yeah, there are tremendous physical and mental and psychological and intellectual consequences to music. The Nazis, by the way, didn't write any music whatsoever. They never wrote any. They stole some music. Now, they did have Wagner, who was sort of lying in wait for them, who had a horrendous concept of this stuff. And in fact, Wagner's whole point was to mush over these distinctions and to turn music into sensual effects. One way of thinking about it is that music is silent. The real music is silent. It's the ideas, it's the concepts. I think a better word than picture is concepts, relations, like the galaxies that Dino was talking about yesterday. Those are the relations which are being generated in the mind by the music. That and also appropriate theological concepts which are being generated at the same time. But that has to wait till the next conference presentation when we look at the 4 serious songs.
Okay, thank you.
Yeah, stay tuned for the next conference.
Nick Clement from St. Louis. My question is for Jonathan or for Will, and concerns the topic of evolution. And my idea sort of is that there is a direction of evolution from sort of less organized species to higher organized species, but it seems from the geometry that the higher species determine the lower species. That is, the circular action determines the linear action. So that seems to me a paradox. Maybe it isn't. I'd just like you to elaborate on that. See my question? I don't know if I said it right.
Well, it is in fact a certain kind of paradox, because of course the Darwinian conception is entirely based upon an evolution which is materialistic, and which in fact is based entirely upon chance when it comes down to it. And that kind of evolution in reality is impossible. The notion of evolution that Cusa develops, as I attempted to indicate in citing various statements that he makes in his writings, is both an ascent and a descent. And in both respects, both the beginning and the end is God. That is, it is an ascent from the center of the universe, which is God, and it is a descent from the circumference of the universe, which is God. And so the direction which evolution has is towards God, towards the absolute infinite. And this is manifested, as he indicates, in a certain kind of appetite.
Be generated between the intervals. On the screen, you now see a list of the musical intervals. Octave, fifth, fourth, major and minor third, major and minor sixth, the half and whole step, and then the augmented and diminished intervals. One of the intervals we will be working with today, in particular, is the fourth. So that you can begin to become familiar with this fellow, the fourth, I would like to ask Margaret to play 2 ascending fourths, C to F, then G to C. And I would like everyone here to please sing them. Margaret, please play Do, Fa, Sol, Do. Okay, I'd like all the ladies first to sing Do, Fa, Sol, Do. And now, would the men please sing the same thing? Rouche has asked us today to conduct a demonstration in which you will participate, in which we will aim to make you more familiar with what is called the well-tempered system and the material from which musical thought is constructed. Musical ideas are not constructed from notes. Musical thought begins with musical intervals. There is a mistaken perception in our culture that these intervals are just distances or interactions between the notes. They are not. The intervals are a primary form of existence, what we should name a form of oneness, from which we can generate a many. The primacy of the intervals will become clearer as we move from looking at intervals to reviewing pairs of musical intervals. These pairs of intervals may involve 4 or even only 3 notes. It is these pairs of intervals which generate the first level of hypothesis in musical thought, namely the alternative choices of interval which can night, most of you here should have heard a concert. It occurred as part of a series of concerts we have sponsored now in several cities, as well as in other countries around the world, in which very fine artists have been demonstrating the power of performing classical music at the God-given pitch of C equals 256 cycles per second, a principle rediscovered in our time by Zepp-LaRouche, which has been effecting a musical revolution. What I am about to do, with your help, is to tell you what you heard last night. To refresh your memory, I have asked John, well, Monica's not here right now, but John's going to, you're going to help him, Margaret? Okay, fantastic. I've asked John and Margaret to present the opening of the 4th song in the Brahms Shuna Magalona cycle. And if you don't have the words with you, that's good, because this time I'd like you to give all your attention to the musical line. Thank you. Since the Council of Florence, this quotation will become important later in our discussion. Since the Council of Florence, great classical music has been a secret weapon for our political faction, namely those who identify man as made in the living image of God. What is it about classical music composition that increases the self-conscious creative abilities of men and women, and thereby strengthens their capacity to defeat the forces of tyranny and slavery? It is impossible to answer that question without becoming more familiar with the material from which musical thought is constructed. That is why Mr.